Hello everyone, welcome to my channel. Guys, today we're going to discuss BCD numbers. BCD numbers range from 0 up to 9 in decimal, in binary, which is 00 zeros, and then 001 up to 1001. In BCD numbers, we have two types of BCD numbers. We have what you call unpackaged numbers. This one. Unpackaged numbers is when we have, let's say, two BCDs. Let's say we have 00, 00, and for example 1001. This is what we call unpackaged BCD number. Why unpackaged? Because the first 4 bit, or let's say the first 4 bit, or the first 4 upper bit, so let's say 0, 0, 0, when we have only 0, the first one, and then behind there we have the lower byte, the lower 4 bit. It's a number that can range from 0 up to 9. So this is what we call unpackaged BCD. So 0, 0, let's say if you have 4 0 0 like this, and then we have 1 0 0 0. This also is a unpackaged BCD, which is the unpackaged BCD. Let's go back. We're going to see what is the unpackaged BCD. So you can read here in an unpackaged BCD, the lower 4 bit of the number represent the BCD number, and the rest of the bit are 0. So this is what we call unpackaged BCD number. So the range here of the lower 4 bit must be from 0 up to 9, and then here in front we must only have 0, 0. Let me take another example. 0, 0, 0, and then we have 0, 0, 0, 1. This also is the unpackaged BCD numbers. So let's go back again. For unpackaged BCD number, we don't have a big problem, but the big problem comes when we deal with packaged numbers. Let's go back here. We're going to discuss now about the packaged numbers of BCD now, or packaged BCD numbers. In the packaged BCD numbers, the 4 upper bits must range from 0 up to 9, and the lower 4 bit must range also from 0 up to 9. This is what we call the packaged BCD. So I can take an example of 1 0 0 0, which is 8, and then on the other side I have and on the other side I can say I have 0 0 0, let's say 1. So this one, the whole of it, this one, it's a packaged BCD number, because the 4 lower bits are BCD, and then the 4 upper bits are BCD also. So this is what we call the packaged BCD numbers. Let's see. So the question is, why are we learning this? That's the question. Why are we learning this in 8051? Why are we learning this in 8051? So it's very important to learn about the BCD numbers, or the BCD system, because we remember on this course we add numbers. We used to add numbers. We have this instruction that we call add. And then this instruction may deal with hexadecimal number, may deal with binary numbers or decimal numbers. So But when we talk about numbers, especially when we talk about numbers, we can't avoid the rules that those numbers involve. So one of the rules that the number involve is those one we call the BCD, that we are studying the BCD number system. So it may happen you are adding numbers, and then the result of that number, you want to save it somewhere, or you want to apply it with another number to give you maybe a final result of 50. So you must know, after adding that BCD number, after adding those BCD numbers, let's say after adding BCD numbers, after adding two BCD numbers, you want to add that result with a number, with any number that I don't know, with any number that can give you 50. So you must know how much this number will give you, what will be the result of adding two BCD numbers. So you can see the important way of learning these BCD numbers. Let's go back to the book again. Let me erase first, and let's go back to the book. So let's take an example. We're going to take an example of two BCD numbers. We're going to take, for example, 17 in hexadecimal. Okay, let me write the example like the way is it. Let's use this example. Move. Let's use this example. The instruction says move accumulator with the value of 17 in hexadecimal, and then they say again move. No, they use add now. We use add instruction. They say now add. They say add now accumulator and the value of 28. So let's see now. Let's calculate. Let's go back to the book and calculate. So if you check in the book this value, they say 17 plus 28. So when we add this number in hexadecimal, because we have hexadecimal, I'm using my calculator. So 17 plus 28. So the result after adding these numbers, 17h plus 28h, the result is going to be 3f. Did you see that? The result is going to be 3f. But check this number. This one, it's a BCD number. This side also, it's a BCD. And then this one also, it's a BCD. Here also we have a BCD. So you can see that. So we have a BCD, BCD, BCD. So because BCD ran from 0 up to 9. So we have a BCD. But the problem, our result, one side, the upper, the 3, it's a BCD number because it still range from 0 up to 3. But the problem is the F. Let me use another pen color. Let me use blue. The problem is the F. The F is not a BCD number because it's not in the range of 0 up, it's 9. It's not in the range of 0 up to 9 because F is 15. So automatically, this is not the result. The microcontroller won't give you as a result 3F. This is not the result. So if you use your calculator, or you use your calculator to calculate, you're going to get this answer. You're going to say the result is 3F. But the microcontroller won't get this result as a 3F, because the microcontroller will understand, because there is a mistake. We understand because we add two BCD numbers, so the result is not a BCD number. So we must fix this mistake. So that's what we're going to discuss here. So when we add two BCD numbers, let me repeat those two BCD numbers. Let me use the black pen now. So we have 0, 0, 0, 1. And then we have 0, 1, 1, 1. And then we have what? 0, 0, 1, 0. And then we have 1, 0, 0, 0. So I'm repeating these two numbers. So the first part here, if I divide by 2, this side, we still have our BCD number, which is our 7. Here we still have our BCD number, which is 8. This side we still have our BCD number, which is 2. This side we still have our BCD number, which is 1. So let's add these numbers now. When we add these numbers, we're going to have 1, 1, 1, 1, which is that F. And then here on top, here if you add, we're going to have 1, 1, 0, 0. Here we have what? 3. So this side, it's fine. We have our 3, it's fine. But the problem is the F. The F is not part of the BCD number. So we must fix this mistake. So in BCD, to fix BCD numbers, in adding, when we add two numbers, two BCD numbers, and then we realize the result is not a BCD numbers, to fix that mistake, we add that part, that 4-bit or that enable. We call this 4-bit enable. This is the enable. So we fix that enable by adding with 6. If here, let's say here it was greater than 9, the result here was greater than 9, we're supposed to add 6 here to solve that result. So, but in this case, it's not that part, it's not a higher, the 4-bit, the 4 upper bit that has problem, it's the 4 lower bit that has a problem. So we must add 6 here. It's 0, 0 like this, and we add 6 here to solve that problem. We still have our 3 this side. So if you solve, we're going to have 1. So we're going to have 1, we're going to have 0, we're going to have 1, we're going to have 0, and then here we're going to have what? 0. Here we're going to have 0. Sorry, let's see. 1, 0, 1, 0, 0, 0, and then we're going to have 1 and then 0. Let me try to clean properly here. Okay, let's see. We're going to have 1, 0, 1, 0, 0, 0 also here, 0 also here, and then 1 and then 0. So this is the result of our calculation. So the result here now, we're going to have what here? 5, and then here we're going to have 4, 45. So this is the result that was expecting. So in hexadecimal, so it's gonna be 4, 5, 8. Let's go back to the book. So this is what I was talking about. This is the result, the proper result for our, when we add those two BCD numbers. So you can see now, guys, this what we call a BCD number. So the result must be 45, not 3F. So I hope you learn how to deal with BCD numbers. So the result when you add two BCD numbers, let me re-explain. The result when you add two BCD numbers, the result must be also a BCD number. So if we don't have BCD numbers, or one of the digit in your result, it's greater than 9, so which means it's not in the range of 0 and 9. So you must add that side. If it's a lower byte, the 4 upper byte, you add 6 here. If it's here, you add 6 here, like in our case. So in the last for the last explanation, I'm going to re-explain this. So let's see now what happens if you are writing a code. So let's see what happens if you are writing a code. The code, they say add two numbers. They say add 17H and 28H. So like you say, you can start. Those who have, you can clear accumulator. Clear accumulator. It's a move. It's a move accumulator with a value. We put the value of 17 in our accumulator. It is H, and then we add accumulator. We add accumulator with the value of 28. So after adding like this, we realize already we're going to have a problem. We're going to have a BCD numbers here. The result, after adding these two values, we realized we're going to have the result will be 3F. So which mean the result will be 3F, which mean it's not a BCD number, this one. So to solve this thing by writing a code, we just write DA and then A. So just write DA and A, which is this side, DA, this instruction, DA and A, DA and A. So let me write it with another pen. To solve this mistake, we write, let me use a DA by writing a code is DA and A. What this line will do in your code, this DA is D. What this D will do in your code, this D will solve this mistake. We'll add this D, this DA, that line of DA, will add 6 to this number to solve that mistake, that F here. So which means at the end, if they say, for example, save that final result in the register 1 and give us the content of register 1, let's say move. Now we're going to say move. We put in register, for example, register 1 A. So the final result here we're going to have in register 1 will be equal to 45 H, like the way we calculate. So you see how we deal with BCD numbers. So this is how we deal with BCD numbers. Adding two BCD numbers, the result at the end must give you a BCD number. If it's not a BCD number, you must fix the mistake by adding DA, this line of code in your program. So I hope you guys understand how to deal with BCD numbers. Guys, please subscribe and then write comment. If you have something that you didn't understand, you can write on comment. So to summarize everything we discussed about the BCD numbers is this last part, this summarize here. We're going to this summarize everything like we discussed here. What happened when you add two BCD numbers? When you add two BCD numbers, if the lower neighbor or the lower 4 bit is greater or are greater than, the result is greater than 9, or if you have a AC which is the auxiliary accumulator, it's 1. So which means if you have what they call it, if you have a carry from this bit, from this side to this side, which is the AC carry, or accumulator, which is the auxiliary carry, which is equal to 1. So if you have a 1 that comes out from this bit to this one, which means automatically we need to add that lower byte, that 4 bit or that neighbor with 6 to correct the mistake. Let's take this example of these two numbers. They say 29 and 18. 29 and 18. So 29, so we're going to have 1 and 18. 29, we're going to have 0, 0, 1, and then they say 18. So 0, 0, and 18, 0, 0, 1 here, 21 and 18. So we're going to have 1, 0, 0, 0. So when you add, remember we have two neighbors. We have this side and this side. So if you have a carry here, if you have a number here and a 1 here, so which means this number here, this result that will be here is not a BCD number. You must add plus, you must add 6 to correct the mistake. On other way, let's go back. They say again, if the upper nibble is greater than 9, so if this 4-bit here in front, the most significant 4-bit, as a result, as a CY, which has a carry at the end, it has a carry that is equal to 1, which means you must add that upper part with 6 also to correct the mistake. So which means if you have a carry, after adding this side, you have a carry, an extra carry, or you have a 1 that comes after here, which means the result here won't be a BCD, you must add plus 6. Let's take this example. When I add this one, I have 1, I add here, I have 0, I add here, I have 0, I add here, I have what? 0. You see, I'm going to have a carry of 1. Let me first erase this side. I'm going to have a carry of 1 here, this one. So automatically this one is not a BCD. Let's send this one here. So we're going to have 0. So we're going to have 0, and then we're going to have 1, and then 0. So which means this part here we don't have an extra. We don't have an extra 1. So automatically this one is a BCD number. This one is a BCD number. But the problem, this side is not a BCD number because you have a carry here. We have a carry which is the AC carry. Here we have an AC carry which is equal to 1, but here the CY carry, the CY is equal to 0. Sorry, it's equal to 0 here. So automatically we need to add 6 here to fix that mistake. So that 6 gonna give us what? 1 1 1 0. There's the result here is 0 0 1 0. So this is our final result. So I'm going to have 7 here, and I'm going to have what? 4. So this is what we're explaining this side. So you see how in general what they summarize everything like a BCD number. So thank you. Don't forget to subscribe, and don't forget to comment if you can't understand, or if there's something that is not clear. I'm going to come back and then re-explain again for you. Thank you. Subscribe, and yeah, sharp.